Dobro, ispričavam se unaprijed, ja ću pričati u engleskom, moj hrvatski nije tako dobar. Možda zvuči sad, ali ovo je sve naučeno prije. Ali ok, ako imate nekih pitanja iza ove prezentacije, onda možete pitati u hrvatskom, ja ću probati vam odgovoriti i vidjet ćemo. Ako radim nekih greška, ispričavam se. Ok, odlično. Ok, let's go. I work at a Slovenian company, Elea IC. We're an interdisciplinary firm working with high-rise, with infrastructural projects, with geology and so on. I work in the tunneling department, but also working in other fields as a BIM manager for multiple projects. One of the projects I'm going to present today is a second track, railway track from Divača-Koper. Previously, I also worked at the university as an assistant. I worked in Switzerland at Leica Geosystems, and I didn't like it and I came back. So it's not all bad. Okay, enough about me. Yeah, as I said, we're working in multiple fields. We're a part of the group, IC group, that mostly works in Austria, but also works in other countries in Europe. We have projects, I think, more around the globe than any other Slovenian and Austrian firm. But let's go to the biggest project that we've done in the past few years. So, second railway track, Divača-Koper. This is currently the biggest project in Slovenia. It's been going on for a couple of years. I'm going to explain why in a jiffy. And we were tasked, once they accepted our offer, to do the main design for construction in basically 1 year for 27 kilometers of railway and 25 kilometers of tunnels. Yay! Easy peasy. And yeah, it was all in BIM. One of the first projects, no problem. Yeah, it's just a small fry, let's do it. Yeah, you can see like just the statistics of the project. This is for construction. We had approximately 10,000 drawings, reports. We had more than 600 partial BIM models. And then we had, I don't know how many file versions, I don't want to count them. I'm going to get to that for the construction part, where it's even worse. And the problem was we had, 1 year to design everything. It was the size of the project, of course. Nobody tackled something like that in the past 25 years in Slovenia in BIM, like actually from ever. And there were going to be a lot of changes and supervision done during the construction. This is also in the tender for the contractor. And of course, there were like a couple of companies that were doing this together, so we had to somehow collaborate on something that nobody in Slovenia has ever collaborated before. So as I said, easy. So why BIM? This was our first question, and we said, if we have this as a requirement, let's just go full in. Don't fake it till you make it. Let's just make it happen. For better organization, let's make it controllable, and let's coordinate everything as much as possible. There are going to be some mistakes, but let's see how we go. So this is kind of the project. I don't know if I can point somewhere. Oh, I can, but it's not showing. OK. So on our left, you're right. There's a town, small town, Divača in the inland, and then there's the Koper port, and in between there's a steep drop of 400 to 500 meters at a length of 10 kilometers. So for the railway, those who work in that know that that's a problem. So this is why there's a big S. One joke. Do you know what's the shortest love story of all times? A love walk around the Slovenian coastline. That doesn't work for Croatians. Yeah, this is why we go to use it for vacations. OK, let's go back to the project. So yeah, the existing conditions, the problem is that this project is separated into two areas. One is completely karst with limestone, caves, and a whole lot of unexpected issues. And the other one is flysch, limestone, sandstone, and it's pretty much predictable. And since there's a vertical difference of about 400 meters, you can imagine that since we're dropping down into the earth, everything's going to be in tunnels. We're coming out like 7 to 8 times, but mostly it's just in tunnels. The longest one is about 7 kilometers. And since we're doing it for karst, we have caverns, caves, variable water levels, and so on. So you can imagine this was fun, very, very fun to design, and even more fun to change during the construction. And I have to point out that digitalization started way before the main design started. And this was because we have GeoRadar, we have all the boreholes were digitized. There was a geological model, preliminary model, already in works when we started our main design. So we only had to upgrade that. We had to include additional research. So some of the digitalization was done previously. So we weren't working on, I don't know, just basic drawings alone. Okay, the project timeline. We started as the Slovenian government and so on. They started like 2005. I was still in high school back then, so I couldn't have worked on this. There were about 17 versions of alignment analyzed, a lot of discussions, which one is the best, which one is the worst. They're all bad, they're all great. How about we go for Croatia? How about we go for Italy? A lot of interesting proposals, but we got the permit in 2012, and in 2020, we designed the whole thing. Then the construction started in 2021, and it's supposed to finish in 2025. We'll see. But yeah, then it goes in operation. So let's jump to BIM. This is why we're here. In the information requirement from the employer, we had a lot of different points to take care of. It was very detailed. It was very extensive. Some of the points didn't make any sense. So we had the conversation with the contracting party, with 2TDK company, which is a public-owned company, and we kind of convinced them through the conversations, through the presentations, that some of the points that they are demanding, it's not that they don't make sense. It's that they're impossible to actually have done from any company anywhere in the world, except maybe Apple or Microsoft. They were very reasonable because they did want the project to be finished. They want some benefits from BIM. They didn't want like impossible requirements. So they lowered the requirements a bit. And then we came to something like BEP, so BIM Execution Plan, that we proposed, that was upgraded by them, upgraded by us, developed further by the contractor during the construction. And now it's, I think it's about 120 pages long, something like that. Jaka, do you remember? Something like that, yeah? Plus the appendixes. So yeah, I'm not going to go through all the points. You might have read them while I was talking. I talk a lot, I know. But the main part was how we're going to model everything, how everything is going to be used during the construction, hopefully, and how everybody should use the model that we're going to produce. That's basically what it was. I'm going to go into detail about some of these points, but that's the whole idea that everybody had to get during the project. So you can see here that this was just the organigram organization chart for the designing. For the contractor, it's like this, just multiplied. But we had, okay, project owner, 2TDK, then project revision, project team leaders, all the designers, and then we had in each of those categories, teams or whatever, we had the BIM junkies or the BIM coordinators. So every single part of the project, there had to be one person taking care of digitalization, BIM, and so on. So everybody had somebody to turn on and say, you're the problem, fix it. And we fixed it. We talked together, we had our own separate BIM coordination meetings, and we fixed everything point by point. And then you came to a new problem, and they again said, fix that problem, you went, and so on and so on. You know how it goes in design. Okay, when we started all the debate of how we're even going to model this, because again, it's a huge project. Slovenia is small, like very small. You know how it is, you can drive through it in 2 hours. And do we even have enough engineers who know BIM who are going to make this happen? We had previous pilot projects like Karavanke Tunnel with Austrians. We had some minor projects, some high-rise projects. And the first thing that we said is, okay, let's separate all the entire project stage by stage, object by object, discipline by discipline, and figure out how many models are we even going to get. We came to a number about 500. That increased to 600 doing the design. But again, we kind of separated them into different disciplines. First, it was geology and geotechnics, based on investigation and research. Then it was excavation and support for the tunnels, which was kind of simplified, but still based on geology and full of information, just not a lot of geometry. Then we went to catenary and rail, which was again quite detailed, sometimes too much. We had to tone it down a bit. Inner lining for the tunnels, which was very detailed because this is where the majority of the drawings come from there. We had earthworks and landscape because we do have about 16 major portal areas which had to be designed in BIM. We had architecture and structures, of course, again, very detailed. Equipment in tunnels and in buildings. Since not all the equipment was, the demand for the equipment level design was not that high for some of the areas. For example, for the ventilation, we just had the elaborate, so it was kind of toned down a bit, but everything else had to be coordinated with the punctures in the walls and so on. And then there were more and more other disciplines that had to be incorporated into the federated model. The federated model itself, again, it was about 12 gigabytes, and it took about 4 hours to generate. So I had a lot of very fun nights doing it, because we did, I think, about 40 or 50 cycles of that. I'm gonna get to that more later. Okay, so at the very beginning, we decided that we're going to have a lot of parametric, as much as possible parametric models, especially for tunnels, also for sleeper on rail, so catenary, railway, and so on, because it's going to repeat. Infrastructure like this repeats all along the way. It's not like we had the roads with the crossings and so on. We just had tunnel, then it's portal again, and then it's tunnel again, and that's it, all the way to the end. And we created a lot of parametric families, mostly in Civil 3D and in Revit. We had to create corridor points, like fixed points on which to append the parametric families. And then we did a lot of how should we put it? It's not programming, it's drawing the lines from one box to the other. So graphical programming in Dynamo. This is how it started. At the end of the project, it looked completely like blocks of code that nobody could understand except the two guys that actually wrote those codes. But it allowed us to do an assembly of distribution of parametric families along the path, along the route, and then to have, let's say, niches and other interventions appended to the main families to modify them. This is an example of how it was done for the tunnel. It was exactly the same thing for the catenary and for the rail. It was very similar also for pile walls and so on, and retaining walls. Okay, so this was the modeling part. Now let's go to the information part, because the requirements was not just to model everything, it was also to include all the information that needed to be in the model for getting the bill of quantities out, connecting it to the models, and getting the timeline for the project. So it was very fun to figure out that there were no existing standards in 2020 for modeling something like this on a scale like this. So we had to come up with our own system of attributes and of like a project standard of all the information included in the project itself. So every single one of the elements that you see on the slides, it has classification attributes. It has, time attributes that are not in this table, but they exist. Location attributes, where in the model they are, and characteristic attributes. So volume, area, length, blah, 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 characteristics. And all of this, we were using mostly, again, Dynamo or Python scripts to fill in as much as possible, like dynamically, or so we didn't have to type it in. But some of the attributes, unfortunately, have to be typed in. So a lot of different engineers in different companies spend a lot of hours typing in all the information that needed to be there, so to connect it to bill of quantities and to the timeline. But they allowed us to do something that we couldn't have done without that information. We had the automatic check rules for all the different, for all the different attributes. So since we knew the location and the classification attributes, we said, okay, for example, this wall has to also have the characteristic attributes for the concrete type, for the length, for the volume. So we could check everything like that automatically. It was a lot of effort to set up the rules, but it worked out in the end. So we also created the rules for clash detection, and we could have some sort of dynamic connection to 4D, 5D, so cost analysis and time analysis. But I'm going to get that in a while. So we figured out that you can have all the different 3D models. It's nice, you can have visualizations, but if you don't have the attributes, you don't have any connectivity to any other products, so you have no BIM project. Yay. Okay, so I'm not going to go through slides. I actually have a video, which I'm going to try and explain while it's rolling. Hopefully, it's not too long. I think it's 3 minutes. So yeah, as I was saying, this is the federated model. You can see all the models were segregated into different groups based on their systems, based on their location. And you can see here the entire geology of the project. And this was a lot of effort, but it was really cool because you had the 33 partial federated models, and you could separate them and analyze them separately. So there was never a point in this project where we analyzed the entire project itself like a whole. We always separated it into smaller sections, into these federated submodels, and we analyzed those. And then when you come to the connection between two federated submodels, you just check the connection between them. And if it's okay, it's good. Okay. So you can see here again that we defined by the system. So yeah, excavation, which is support for temporary support for portals and for the tunnels, for the inner lining, for the final terrain, even for the trees with the lollipop sticks and so on, as simplified as possible, and for the entire systems inside of the buildings and the tunnels. And this all had to be coordinated, and you can imagine that it's an issue if you have a coordination clash for the entire model, like 6 kilometers, 7 kilometers of elements that clash with the whole system. So what we were doing at the beginning is just checking some of the sections, like one part of the tunnel, and checking if that is coordinated with all the other systems. And then we just extrapolated from there, because it's easier and it makes sense. Okay, you can see here that all the attributes, all the elements, I could pick any other element, it's the same. They have the classification, location, and description attributes or characteristic attributes. And we could filter on that, because you can set up dynamic filters, and this is how it was used for 4D and 5D. You can see here you have the bill of quantities, so how should I call it, structure, down below. And I can filter based on the chapters in the bill of quantities. You can see the bill of quantities, we have it here. If I want to filter by one of the pay items, I can click on that and see, okay, this is what it's included in the model. And from there, we can extract the quantities based on the formulas, and we got exact quantities from the models. You can then multiply them or whatever, do an addition, minus, and so on. But it was directly linked to the BIM elements, so anybody who had some programming skills could pull it into any other software, because this was an Excel spreadsheet, because the filters were written there. And they could check in any other software if this is correct. And it was the same process for the 4D. For the 5D and 4D analysis. And of course, we used it for promotion, nice pictures for the public, and so on. Okay, let's go back to the main issue, collaboration or coordination. When we were doing the design, we were using Revisto. Now we are using Dalux currently during construction. We were always doing a visual check if something's completely wrong, like the geolocation is like completely far off. Then we were doing the conflict check the clash detection, the attribute check. Then we reviewed the results, if you can fix it internally, or if it could be just pushed on to external checkers. We then communicate and coordinate it. We fixed those things, we updated the project, and then we started all over again. This was done twice, internally, and the second time externally. And it took about, I think, 2 weeks to do it once. We found out about 5,000 major issues, which we fixed. We found a lot more that were so minor that we agreed to ignore, like just like certain edges clashing into one another, which don't make sense. And within 6 months, we kind of fixed the whole model up to the standard it was demanded to be. Okay, what it also enabled us. It enabled us to have the checking of the support types with the geology model. We could compare different variations and evaluate them for portal areas. Since we had all the models there, we could improve on the drawings of on the general drawings. So we could attach different 3D views or visualizations, how it should look like, how it should be built to the drawings themselves. Like this, you can see the formwork drawing. And we can also check the feasibility of the construction. Because some of the staging of the entire construction process were very, very, very crucial, so we checked those. Okay, time and budget analysis. It also enabled us to do some very specific analysis for quantities over time. This is one of the analysis where we were looking. Actually, the client was looking for an answer if there's going to be enough limestone to be used, to be crushed, and then used as aggregate for the concrete in the whole process, in the whole project. And we could do that analysis. And we figured out, you can see the golden line here, this is how much is left. And you can see while it was being constructed, while the limestone was being excavated, we were getting more and more of it. And then you could see this is where the excavation should stop, like it was predicted to stop, and then we were just using that limestone until the end. And the predictions pretty much line up with the actual construction setup and the construction timeline. The other things that we could also do, we could check what's being built currently. The BIM supervisors could then present that to the client, and the client could then compare if they are in line with the cost and the time schedule. It's going to be a spoiler alert, but they're not. Much surprise to everybody. Okay. Of course, since we are working with ground conditions, which we don't really know what's going on there based on all the research, although how extensive it could be, we don't know. But we already knew at the beginning that there are going to be a lot of changes. So we were using, or the contractor is using, the traditional surveying methods, which are slow but very precise. And they're also using a lot of laser scanning and photogrammetry, mostly to get analysis of the tunnels, the deviations. This is something that can also be done just like, this is off the topic of BIM, but just the digitalization as a whole. Which all the new tools enable us to do stuff like this, to actually model the carscapes, to have a visual representation of where they are based on the very, very preliminary laser scans. So for this cave, for example, there are only like 400, 500 points, but you get a really good view of where in the space itself the cave is, so where we should put additional support elements and so on. And then we can also compare the open track earthworks based on the point clouds, if they've been excavated, if they've been filled enough, and so on. Okay, so what are they currently doing? The excavations are coming to a close this year for all the tunnels. For the shortened tunnels, it's already been done. And for all the tunnels, the contractor had to fill in the forms digitally on Dialux. This is how it looks like in the database. And then we took that database, we transferred it to our favorite tool, which is Excel. And from Excel, we connected it to all the other softwares, which generated the geometry. This is how the code looks like now. If you remember how it looked like before, this is completely different. And then we generate all the final excavation and support models each month. And then they can be checked if they are correct, if they are in line with expectations, if they're in line with the reports, and so on. And then we export to IFC, because this is the standard for the OpenBIM. So this is the process for excavation. Currently, they're doing the inner lining. The inner lining is a bit different. We don't generate that. We just tweak it because the contractor does some changes, and we have to do the changes too. But they do have to fill out all the forms of what's being done when based on the positions in the inner lining. So, conclusions. Only 5 minutes over, yay. Okay. I'm going to be speaking just for the design, but it also applies to the contractor. But I can't speak for the contractor. They should be here and speak for themselves. BIM does improve communication. Not just because you solve issues, but because you can actually see issues. You don't just point to a line and say, this is in clash with that, fix it. You actually point to an element to say, look, how about we move that like 3 meters down? How about we switch it and we go around it? And we're currently doing that for quite a lot of smaller objects on the track. And we're just figuring out that some of the issues would not be possible to be solved just with 2D. So even the designers who were totally against using 3D and BIM are now coming around and saying, yeah, you know what, give us the model and we'll figure out what we can do with our model to check if it doesn't clash. And then we'll do the drawings. It was completely the reverse of what was going on for this project in 2015-16. So it improves, as I said, quality control because you can check things. We can optimize the design solutions because we can compare different solutions just on screen, and then you can also have takeoffs of that and figure out if it's cheaper or not. And more or less, you can have a uniform and coordinated project documentation. That means that everything's coded, the machines can read it, humans not so much, but you get used to the code, but it's all. When you upload something to the common data environment, the common data environment knows exactly what to update. It has all the backtrack, all the logs, and you can always go back and check what the versions were and what was changed in between the versions. And then, of course, you have better understanding of the project, and you have the spatial data acquisition at the construction site, which I was just showing. So what could be done in the future? As I was saying, digital daily, monthly reports, maybe. For some works, definitely. For some, maybe still too much to ask for. Completely digital approval workflows. What we figured out is that contractors actually want this. Designers want this. Clients want this. Supervision doesn't. Ask them why. I don't know. Maybe augmented reality. Some of the contractors have been asking us if we could implement that, not in this project, but some of the others. I'm not an expert of that, but let's see what the future holds. And maybe also AI-supported facility management. For this project, the Slovenian railway company has their own system in Maximo. They cannot transfer the BIM models, but we're going to extract the information and then put it in their Excel file so they can import them into their facility management system. We'll see how it goes, but maybe it will work. Hopefully, yes. And then again, it depends if we embrace the BIM, if we embrace the digital, or if we just stay in the era of 2D and comparison of lines instead of comparison of models. So yeah. I think that why we should digitize our projects, why we should use BIM, is to better organize the projects, to have control, and to actually collaborate and coordinate efficiently on the projects. So yeah, it still needs to be improved. We should have standards. It's not perfect. In Slovenia, we also don't have any standards. The only demand currently is that by the 1st of January next year, all the major projects should include BIM. What that means, nobody knows. So that's something that we also have to work on. And for me, one of the most important points that nobody talks about is we have to educate the clients. So they don't demand a kilo of BIM So they don't have the requirements like through the roof. They have actually realistic requirements that are going to help them have a better project. And that's basically it. This is what we learned from this project, and we're going to apply it for all the other projects. So thank you very much.